Welcome to ACE Engineering Academy and ACE Online. Here we are going to discuss about the compiler design revision series 2025. Right, and compiler, we know what are the topics. In compiler design, we have 5 topics. That 5 topics are called 5 phases of the compiler. The first phase, lexical analysis, and the second phase is called parsing. And third is semantic analysis, we call syntax directed translation, and fourth is intermediate code generation, and fifth is code optimization. And the sixth phase is code generation, that is not part of the syllabus. These are the 5 topics in your syllabus. As we know that the most importantly, the many times questions are repeatedly asking on parsing techniques. And parsing is a big chapter. It requires to know the grammars, context-free grammars, top-down parsings, and bottom-up parsing. It is a big chapter. And questions were asked, mostly 1-mark questions on lexical analysis. And compulsory every year, you are getting a minimum of 1-2-mark question from the syntax directed translation. And recently a question came from intermediate code generation also, but previously from intermediate code generation there are very few questions were asked, but intermediate code generation also started asking questions, so you can focus on it. And code optimization, also one of the important topic. In that there is a topic called liveness analysis. On that liveness analysis also in 2023 question asked, 2021 asked, right? And more scope is there for asking more kind of questions. That kind of questions, what is going to be asked, that we have discussed during our live sessions, offline classes, online classes and recording lectures. Fine. Now without wasting time, we'll go ahead with the revision series. And before I start with revision, just I wanted to give a clear picture, like what was the weightage, like what was the weightage that was asked in the previous GATE examinations. Here I have analyzed papers from 2017 to 2024. And look at in 2024, in both the sets of papers, there are 2 sets of papers, set 1 and set 2. In both the sets of paper, there is a 8 marks from the compilers. 8 is a very good marks. Look at in the parsing chapter, only 4 marks asked, 2 1-mark questions and 1 2-mark questions. In syntax directed translation, 1 2-mark questions and 1 optimization, 1 2-mark questions. Totally 8 marks from the topics from the CD. And in 2024, there are 2 2-mark questions of parsing and 1 2-mark questions on intermediate code generation on triples in triples representations. And total 8 marks from CD in 2024. In 2023, it is 6 marks. In 2022, it is somewhat less, 4. And again, 2021, you have 6 marks. In 2022, 6. And in 2020 it is 4 marks, and 2019 6 marks, in 2018 5 marks, and 2017 in both sets there are 4 marks. Now by looking this, what we understand from compiler, you can get an average of 6 marks from the subject, and moreover compiler is one of the smallest subject among all the subjects of GATE CS, and compiler design is one of the small subject and easy subject. I cannot say easy, it is depends on you, but some people feel it is difficult, and but I feel it is easy because questions we can predict it, what kind of questions are coming and how to tackle those questions. That kind of questions we have discussed, enough number of questions we have discussed during offline and online classes, right? Okay. So spending a small time to get 6 marks, and as I was keep on telling during my lectures, 90% chances are there we can expect the questions. Like as I told you in the during the live classes and physical classes, I told you what are the chances of getting a questions. That guessing 90% is possible from where questions are going to ask. So, and also I have explained to you what are the predicted type of questions, expected type of questions, previously asked questions, and so many questions that we have practiced. And it is easy, and you can score full marks from the compiler design if you have attended all my physical classes and online classes and also recorded lectures. Okay. So, this is about the weightage analysis. Now, we will continue with the first chapter of lexical analysis. Okay. In the lexical analysis, we have seen the basics, like what is compiler. What is a compiler? Compiler is a language translator which translates a source program into target program. And what are the target programs? The target programs are assembly language program, relocatable machine code, absolute machine code. We have seen the differences, and we have understood how the processing system works, means how the program that we have written is to be converted into executable target program. In that process, only compiler is not suitable. In addition to the compiler, we have seen what is the importance of preprocessors, assemblers, linkers, loaders, other language processing systems also. And we have discussed what is interpreter and why interpreter is needed and what are the differences. And also we have discussed how compilers are developed from one programming language to another programming language. The concept we have seen, bootstrap. Similarly, from one machine to another machine, we call it as a cross compilation. So, we have discussed various other concepts. We have discussed about interpreter. These are the basics. Assembler and linker, loader, and designing of a compiler from one programming language to another programming language we call bootstrapping. And we have cross compiler to generate a compiler from one machine to another machine. These are all the basics that we have discussed, and on the basics you may get a minimum of 1 mark questions. And also we have discussed the phases of compiler. Phases of compiler, and especially on this phase of compiler, when you see the previous gate questions, there are match the following kind of questions are asking for 2 marks. Match the following kind of questions, like phases is given, input to the phases and outputs of the phases are given and asked to match it, and phases are given, and what are the different types of machines that will be used, like for implementation of parsing we use as a context-free grammar uses a recognizer, PDA, like these kind of things are given and also possible to give as a match the following kind of questions. Even in 2024 also one question asked on match the following on phases of compiler. Okay. But when it comes to the first phase, lexical analysis, what are the possible questions? You will be given a program snippet and asked to find the number of tokens in the program. Now, what is a token? Token is a sequence of characters having some meaning. Like tokens are of type called keywords, identifiers, special characters, operators, numbers, constants, and so on and so on and so on. Right? What you have to do, you have to see how the program can be divided into sequence of tokens. Okay, and you will be given a program snippet and asked to find number of tokens. This is one kind of questions possible to be asked. And another question which was asked in 2018, and they have given some token patterns. Token patterns are given, and along with the token patterns they have given an input and ask it to find which token stream is the correct one to derive this input. Like means for this input, what are the token patterns, what tokens are going to be generated. That kind of questions asked in 2018, and still there is a scope of asking that similar kind of questions on this. So, first type of question, number of tokens, second is token patterns, and input is given which tokens are correct one. And basic questions on phases of compiler and match the following kind of questions. And these are the three types of questions asked from the topic of lexical analysis. And what is expected? The expected type of questions means, because it is regular where these kind of questions are asked, but when it comes to the expected type, so far questions are not asked on the Lex compiler. So scope is there on Lex compiler, because Lex compiler is called Lex tool. Lex tool uses a Lex language, and the Lex program will have three parts: the declarations and auxiliary procedures and regular definitions, that the parts of Lex program, and how Lex program is going to be compiled. When you compile the Lex program, we are going to get a program called lex.yy.c. It is a C program. That C program contains the tabular representation of transition diagram constructed for the regular expressions that are mentioned in the Lex program. So, basics, at least you can expect 1 mark questions on the basics of Lex. This is one expected. And the second expected is the type of lexical errors. Lexical errors. What are the type of lexical errors? We have unterminated comments, nested comments, length of the longest identifiers, invalid identifiers, invalid constants, illegal symbols. We have discussed these things. So, expecting, you may be given some program snippet and asked to find in which phase of the compiler it is going to identify the error in the program. So, if it is a lexical error, this is going to be identified in the lexical analysis phase. If it is a syntactical error, it is going to be identified in the syntax analysis phase, as we know it. If in order to know in a compiler that program snippet is going to be an error, but that error is going to be identified in which phase of the compiler. That could be a question, because that kind of questions were asked in the previous GATE exam, right? So, that could be one of the possible and expected type of questions: lexical errors, lex and lexical errors. These are the expected type. Okay. So, the basic fundamental theoretical questions on phase of compiler match the following, and ask you to find number of tokens and token patterns, and input is given which tokens are the correct for that input. These are the three type of questions that were asked, and these are the expected type. Okay. Quickly, we revise this first chapter with respect to the questions. Now, here have a look. There are some theoretical questions on basic fundamentals are possible to be asked. Here, these are some of the possible questions. A programming language does not allow integer division operation. This is generally detected in the phase. This is generally in the phase of which phase it is going to be detected? A programming language does not allow integer division operations. In which phase it is going to be identified? A programming language does not allow integer division operation. This is generally detected in the phase of which phase it is going to be identified? Lexical analysis, we have known what are the errors possible, and it is not a syntactic error. It is called semantic error, correct? Na? It is a semantic error. Means semantic, it is a rule that to verify it should not allow integer division. That rule is going to be verified. So, answer for this question is option C. And intermediate code helps in. What is the purpose of intermediate code? These are the things we have discussed in the phase of compiler. The basics on phase of compiler, theoretical questions, 1 mark questions are possible. Intermediate code helps in what? See, why intermediate code is required? Suppose we have a program and that front end of the compiler is going to convert this program into intermediate code, and this intermediate code is given to the back end part of the compiler, and so that it is going to generate a code for that particular mission. Suppose if I want to generate the target code for mission 2, so it does not require to change the front end. This intermediate code will be given to the back end 2, so that it is going to generate a target code for mission 2, and so on. It is a meaning that the same intermediate code can be targeted to different backends to generate the target code for different missions. This is what we call retargeting the code to different backends to generate the mission code for different target missions. Error handler helps too. Why error handler? Why error handler? Just answer the question, why error handler? What is the purpose of error handling? Error handler, is it going to rectify the errors? No. Suppose if there is an error in the compilation, it has to see what type of error, where is the error, and that information is to be collected and reported to the programmer. Whenever it is reported to the programmer, then to the programmer debugging becomes easy, right? But error handler is never going to rectify it. It is going to report it. It is going to report multiple errors, but it never rectifies. So, what is the correct answer for the question? Option B. It is going to report the errors, but not rectifying the errors. Now, which of the following is not a token? Tell me. Which of the following is not a token? Now, what are the tokens? It is a sequence of characters having some collective meaning. Keywords is a token. Name of the function. Function name can be used as a identifier. Means identifier can be used as a function name. Identifier is a token. Variable name to store the value. That is also, variable names are called identifiers. Identifiers are also called tokens. But when it comes to the expressions like a plus b, expression is not a token because expression is a collection of tokens. The question is about not a token because the question is about not a token, expression is not a token because expression is a collection of tokens. Now tell me about this. Which of the following operations are done on symbol table during lexical analysis phase? This is multiple selection question, MSQ. So what operations are possible? Which of the following operations are done on symbol table during lexical analysis phase? What is the functions of lexical analysis? The functions of lexical analysis is removing white spaces and comments, identifying the tokens. Third thing, store the identifiers into the symbol table. Means it requires to create a record for identifier in the symbol table to store the necessary information about the identifiers. And suppose some identifier subject 1 marks, okay, sub 1 is stored into a symbol table, like its type integer, its initial value 0, and so information is there in the symbol table. When this was stored, suppose whenever it is scanning the program, while scanning the program there is a declaration statement in sub 1 and assuming that is stored, right? And next time whenever again it is used sub 1 equal to 5, again it is used sub 1 equal to 5. So means whenever again it sees an identifier, is it required to create one more record? No. Why? Because that sub 1 is already created. It means it has to check whether that record for that identifier is already present in the symbol table or not. So that is called a lookup operation. Yes, it looks. Is it already present? If it is already present, is it required to create one more record for that identifier? Not required. Okay. And insert, here you look at insert. Suppose if that record is not present, assuming if that record is not present, suppose whenever it has seen an identifier sub2, it will look if sub2 is present. If it is not present, it has to insert a record or create a record for that sub2 with their values in the symbol table. Insert. Is it going to be deleted, that identifier records? Lexical analyzer is not going to delete that records for that identifiers. Why? Why it is not required to delete? Because it is required to be maintained to be used by the further phases of the compiler. Because it is to be used by the further phase of the compiler, it does not require to delete it. It won't delete it and it won't reset it. So, what is the correct answers? A and B. Okay. And as I told you, the type of questions that were asked and possible to be asked is the number of tokens in the above code is. The number of tokens in the above code is. Now, find out how many tokens in the program and answer it. How many tokens? 1, it is 2, 3, 4 into 5, 6, comma, you have to count 7, B 8, comma 9, C 10, comma semicolon 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, comma 27, printf 28, it is 29, whatever is there in the double quotes is called a string constant. This is about 30, 31, 32, 33, 34, here I got 35 is the correct answer for the question. Okay. And some people have given 27, 37, 34, even one small mistake will pay you a lot, right? You have to pay you a lot. So, it is about answer for the question is 35. And another type of question is match the following. These are the regularly asked questions. Here have a look, it is a match the following. It is given P, Q, R, S, the phases, and these are 1, 2, 3, 4, 5, 6. Now, what are the correct matches? Match the following. Here semantic analyzer. What for semantic analyzer? Here a semantic analyzer is not a backend, and postfix notation we know that it is for intermediate code generation. Eliminating redundant code means extra code is eliminated. It is in the case of optimization. Type checking is done in the semantic analysis phase. Now, P matching with 4, because P matching with 4, so option A, C, D are wrong, B is the correct. Finish. And the parser is called syntax analyzer, and it is going to report syntax errors if any. So, Q matching with 5. Code optimization is going to eliminate the redundant code, R matching with 3, and target code generation is called the backend. S is matching with 1. So, answer for the question is option B. So, means you should have a clear idea about what is the input to the phases, output of the phase, and what is the purpose of the phase. And these things you can focus. So, maybe 1 mark questions are possible. Fine. That is about the first chapter. It is more of basics, and basic kind of questions are possible to be asked, and those are the type of questions I have shown you. Okay. Mostly you can expect 1 mark question, but still there is a scope for asking 2 mark questions on lexical analyzer. And next we go to the next chapter called parsing. And as I told you, parsing is one of the important chapter. And when I have shown you the previous weightages, and I have shown you that parsing is a topic from where more marks are asked. In the parsing, is used to verify the syntax of a programming language. It is to verify the syntax of a programming language. To verify the syntax of a programming language, it is required to use a grammar, because how to define the syntax? Syntax of a programming language is defined using the grammar. The what type of grammar that we use to define the syntax of a language? That is context-free grammar. CFG we use it. Context-free grammar is used to define the syntax of a language. And once syntax is defined, it has to verify the sentence is syntactically correct or not by grouping the tokens that are generated in the lexical analysis phase. If the sentence is syntactically correct or not, it has to be verified by using either top-down approach, we call top-down parsing, or bottom-up approach, we call bottom-up parsing. There are two approaches to verify whether a particular sentence in the language is syntactically correct or not. So, we have three topics in the parsing about how to define the syntax using the grammar, context-free grammars and their classifications. And we have seen how it is going to group the tokens to form the sentence to verify whether the sentence is syntactically correct or not using top-down parsing and bottom-up parsing approaches. Fine. So, what questions you can expect? First, we will talk about questions on context-free grammars. We have discussed the grammar classifications. Context-free grammar had a classification that one based on number of derivation trees and another is based on number of input strings that it is deriving. Based on number of derivations, we have ambiguous grammars and unambiguous grammars. Based on the input strings, we have recursive grammars and non-recursive grammars. Again, in recursive grammars, we have a classifications: left recursive, right recursive, general recursive. Those are the type of grammars that we have. Okay. So, we have seen that derivations, questions are possible on derivations, derivation of an input sentence using the grammar. A derivation can be either leftmost derivation or rightmost derivation. When I can call a derivation is leftmost, a derivation is said to be leftmost if at every step in the derivation, leftmost non-terminal is going to be replaced. A derivation is said to be rightmost if at every step rightmost non-terminal is replaced. Leftmost derivation as well as rightmost derivation. Derivation is of two types. And questions were asked on derivations, like you are given a grammar and input sentences are given and asked to know which input string is derived by the grammar. This is a one kind of question. And second is, it means input is given and asked to know which inputs are going to be derived using the grammar. And second thing is, suppose if input is derived using the grammar, the question is number of derivations. These kind of questions we have discussed. How many derivations are possible, or number of parse trees possible for that input sentence. This is one kind of questions which were asked in the previous gate, and this is a scope for asking questions. Input, number of derivations. And second is the conversion of ambiguous grammars into unambiguous. When we can call grammar is ambiguous, a grammar is said to be ambiguous if it has more than one derivation, more than one leftmost or more than one rightmost derivation for some input sentence. It means even for one input sentence of the grammar, means one input sentence generated by the grammar, if you have more than one derivation, one leftmost or more than one leftmost or more than one rightmost derivation, we can call the grammar is ambiguous. But the possibilities are conversion of ambiguous grammars into unambiguous. So, what are the possibilities? We can go with a trial and error method because we do not have algorithms. Another is redefining the precedence and associativity of the operators. So, previously almost 6 times questions are asked on precedence and associativity. Even in 2024 gate also one question asked on precedence and associativity. So, scope is there for asking question on precedence and associativity of the operators, precedence and associativity of the operators. So, you will be given a grammar and asked you to verify which of the following is correct. They are going to give you some precedences and associativities, like which precedence is correct, like plus has least precedence than star, star has higher precedence than plus, some statement kind of statements you can expect, and which statement is going to be correct based on the precedence and associativity. This kind of questions are asked. It's totally including 2024 gate question, there are totally 8 times question asked on precedence and associativity. Definitely I can say it is very important topic because multiple times questions are asked. And the third one, questions based on the number of input strings. Based on number of input strings, we call recursive grammars and non-recursive grammars. But on recursive grammars, we had a questions on left recursive. We had a questions on left recursion and left recursion elimination. Left recursion and left recursion elimination. But what is expected from the context-free grammars? Those are the topics from where questions were asked, and what type of questions are asked I have explained. But when it comes to the expected type, so far no question is given on left factoring. Left factoring is a possible question. But on remaining all the topics on context-free grammar, I am talking about just only one thing. On context-free grammars, questions were asked. But left factoring, exclusively on left factoring, no question asked. So, maybe a possibility that you will be given a grammar and asked to left factor the grammar, and after left factoring, what is the solution? And that could be a expected type of question. Okay. So, next we will go ahead with some questions related to context-free grammar, then we go ahead with the top-down parsing, then continue with the bottom-up parsing approaches. And when it comes to the parsing approaches, so we will discuss in more details about parsing, and as we know that parsing can be of two types, either top-down parsing or bottom-up parsing. In top-down parsing, we have a techniques brute force method of parsing, and second is recursive descent parser, and third is predictive parser. And predictive parser uses a grammar called LL-1, then the parser is called LL-1 parser. In bottom-up parsers, we have a shift reduce parser, and we have operator precedence parser, and we also have LR of K parsers. In LR of K, we have LR of 0, SLR of 1, LLR of 1 and LR of 1. And questions related to that, you can expect a question. You can expect a questions from that LR of K. And in the previous gate, questions were asked, like they are given saying that which of the following is a top-down parser, which of the following is bottom-up parser, that kind of questions are asked. And next possibility is on precedence and associativity. Have a look this question, and it is a MSQ, and solve this question. So, what is the precedence and associativity? Here the question is about associativity. Here you look at the operator plus. Now, what associated follows? the leftmost symbol in the RHS is same as LHS. If the leftmost symbol in the RHS is same as LHS, what happens? E tends to E plus T, if we apply repeatedly, it is going to skew to the left side. If it is going to skew to the left side, the evaluation is left to right. It means which operator is going to be evaluated first? Leftmost operator is going to be evaluated first, then I can call plus is left associative, correct, but not right associative. And what is recursive grammar? If the same thing, if the leftmost symbol in the RHS, if same as LHS, we can call left recursive grammar. Then we can call option C is also correct and right recursion is incorrect, right? What is the left factoring? Left factoring is nothing but isolating the common parts of two or more productions. Suppose we have S tends to small a, capital B, small a, capital D, small a, capital A, simple. Now, what is common in this? A is a common. Because A is a common, we can factor the common parts, means isolating the common parts is called left factoring. So, what is common A? The remaining parts we can call S dash. With S dash I have to show remaining. So, in the first one the remaining part is B, in the second one D, in the third one E. So, isolating the common parts of two or more productions, common part is A, that isolation of common parts of two or more productions is called left factoring. Now, another question on precedence and associativity, even this kind of question asked. They have given a table, that is, consider the operator precedence and associativity rules for the integer arithmetic operators given in the table. Some operators are given, precedence and associativity is given. The value of the expression as per the above rules, and this kind of question asked in 2015 and also asked in 2024 also. Okay, scope is there for asking question. Just look into that. What is the highest priority? Highest priority is given to plus. And here you can see there are 1, 2, 3 times plus is there. But associativity is left, means left side plus is going to be evaluated first. Means first 3 plus 1, 4. Then 4 plus 5, 9. This is 9. Star 2 division. Here again one more plus is there, that plus is having higher precedence. So, 7 plus 2 is to be evaluated, that is 9. So, 9 star 2 division 9 minus 4 minus 7 minus 6 division 2. Okay. This is after considering plus. Next is minus having higher precedence. How many minuses we have? 1, 2, 3 times we have minus, but it is right associativity. So, means right side minus is going to be evaluated first. So, means this one 7 minus 6, 1, then 4 minus 1, 3, right, then 9 minus 3, 6. So, 9 star 2 division 6 division 2. Okay, that is over. So, how we have done? Because right associative, right side first is done. 7 minus 6, 1, 4 minus 1, 3, 9 minus 3, 6. Okay. Next, all minuses are over. Next, precedence is given to the star. And how many stars? We have only one star. So, 9 star 2, that is 18 division 6 division 2. And last is division. 2 divisions are there, but right associativity. Right associative means first rightmost. 6 division 2, 6 by 2, 3. Next is 18 by 3, 18 by 3, 6. So, answer for this question is 6, that is it. So, it is a normal expression evaluation based on the precedence and associative, but do not follow general rules, follow the rules that are given in the assumptions. That is important. Next one. The questions on elimination of left recursion. Some student was asking me to explain the left recursion also. Okay. What is a rule for left recursion? When I can call a grammar is left recursive, A tends to A alpha or beta. If any productions are of the form A tends to A alpha or beta, we call it is a left recursive production. Why it is called left recursive production? Because the leftmost symbol in the RHS is same as LHS. If the leftmost symbol in the RHS is same as LHS, we can call left recursive grammar. If the grammar is left recursive, how we have to eliminate it? We can rewrite the production rules as A tends to beta A dash and A dash tends to alpha A dash or epsilon. And this will be used as a formula, but I never suggested to remember as a formulas in any of them. So what I suggested, proof you understand. What is happening? A tends to A alpha, again A is to be replaced with A alpha, you are going to get like this. Again A is going to be replaced with A alpha. So what is going to happen when you repeat it? You are going to repeat alpha, 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 right? And to stop this process, this first A, instead of every time repeatedly applying A alpha, A alpha, A alpha, you have to replace with a beta, so that it is going to become beta, and this repetition of alpha, 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 I can call A dash. Now what is A dash? The repetition of alpha, 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 alpha. So to get that, we can write alpha A dash, so that every time A dash is there, alpha A dash, alpha A dash, alpha A dash, alpha A dash, so that you can have a repetition of alphas. And after certain number of alphas, we have to stop the process now, because we have to terminate and to derive the sentence. To stop the process at some number of times, after some number of times alpha repeated, that A dash should become epsilon, that A dash should become epsilon. So this is how formula is derived. So it requires to observe what is repeating in the grammar production. Suppose S tends to S, A, B, D, E. Now is it left recursive production? Yes, that is a left recursive production. So every time S tends to S, A, B, S, A, B, S, A, B you apply, it is A, B is going to be repeated. And that repetition to stop, that S should not be repeatedly, it is repeatedly applying the first production itself. To stop it, you can go with the second production. And this repetition we can call S dash. With S dash, we are going to get the repetition of ABs. To stop the repetition, epsilon. That's it. You have to solve the left recursion elimination in this way. So just observe it, what is repeatedly appearing, and with which you have to stop the repetition. That is important. This is about left recursion. And questions were asked on left recursion in the previous gate, and still there is a lot of scope is there for you to get a questions on left recursion. Here is a question. The grammar which is equivalent to, okay, this is a grammar that is equivalent after elimination of left recursion. Just check where is the left recursion and what will be the answer after left recursion. Okay. So where is the left recursion? This is not left recursive grammar, because leftmost symbol is not same as LHS. This is a left recursive grammar. This is a left recursive. Because here is a left recursion, the repetition is BA here. Here is a left recursion, repetition is small a. There is no change in the first production. Here no change, no change, no change, no change. And here this is going to be replaced. A tends to, that first A can be replaced with the second B. Repetition we can have A dash. And moreover, A dash should be the repetitions of capital B, small a, capital B, small a, and A dash, and to stop the repetition, epsilon. And do you have that production? This is left recursive directly, it is eliminated. and here B A dash correct, B A dash or epsilon correct. B A dash correct, B A dash and epsilon. This is also correct. And here A tends to B A dash or epsilon, correct. Okay, happy. And but second production is also there, B, and in the B production, the first B in the RHS to be replaced with the second production A, B dash, and B dash should be the repetition of small a capital A, and that should be replaced with epsilon. So, A B dash, A small a capital A B dash or epsilon, perfect. So, answer is option B. And here it is given only A B dash, but the repetition possible with B dash is not mentioned. So, C wrong, and here B production is completely removed, that is wrong. So, correct answer for the question is option B. Okay, all of you answered correctly, happy. Next, look at the possibilities. When we go for top-down parsing approaches, in a top-down parsing approaches, we have recursive descent parser, brute force method of parser, and brute force method and recursive descent parsers are outdated, but still we have discussed those things, and that are possible to be expected at least 1 mark questions in the upcoming GATE examination. Whatever I have discussed, just go through it, that is sufficient. And questions are possible on predictive parsers, and we know that predictive parsers are going to be constructed, and which is based on the 2 functions called first and follow. Now, what is the first set? So, it is going to determine the first symbols that are possible when you are deriving with some production rules. Suppose if A tends to small a, then we know that first of A equal to A, means if the symbol, if the production is starting with a terminal, then the terminal will be the first set, means if A tends to A alpha, so because it is started with a terminal, that terminal in the first symbol. If A tends to epsilon, then first of A equal to epsilon, means if the right hand side we are deriving epsilon, then epsilon in the first set. Suppose if we have a production of the form A tends to alpha 1, alpha 2 dash dash alpha n, assuming this alpha I belongs to either V or T, assuming. What does it mean? Just one V or one T, means one non-terminal or a terminal. What we can say, the first of A, tell me, is always first of alpha 1, correct? First of A is first of alpha 1. If that first of alpha 1 is a terminal, the terminal you can say. Suppose if the alpha 1 is deriving epsilon, if that alpha 1 is deriving epsilon, it is meaning that A production is starting with alpha 2. So that we have to consider alpha 2 when alpha 1 is becoming epsilon. The second rule is, if first of alpha 1 contains epsilon, then add first of alpha 2. Then add first of alpha 2 to first of A, correct? And suppose if alpha 2 also containing epsilon, we have to look for alpha 3. If alpha 3 also contains epsilon, we have to go with alpha 3, first of alpha 3 and so on. And suppose if first of alpha n also contains epsilon, it means that alpha 1 to alpha n all are becoming epsilon, means the complete RHS is becoming epsilon. When complete RHS is becoming epsilon, then the right hand side of the production is becoming epsilon. When the right hand side of the production is becoming epsilon, that epsilon is there in the first set. The third point is, if first of alpha I contains epsilon, this is for all I equal to 1 to n. For all I equal to 1 to n, first of alpha is epsilon. Then that first, then epsilon to be added, then epsilon to be added to first of A, correct, to first of A. So, simple these rules. If it is started with a terminal and terminal in the first set, if it is started with a epsilon, means if it is containing epsilon in the right hand side, epsilon. If we have the productions, right hand side may have combination of terminals and non-terminals, always first of A is first of alpha 1. If alpha 1 is a terminal, stop, over. But if alpha 1 containing epsilon, then add the first of alpha 2, and if alpha I contains epsilon for all 1 to n, then add that epsilon. These are the rules for first. These are the rules for first. Okay, these are the rules for first that we have discussed, some problems we discussed. And when it comes to the follow set, now what are the rules for follow set? And we have discussed follow of S is always dollar. Why follow of S is always dollar? Because input is to be derived using S, and when parsing that input is ended with a dollar, which is called end marker. So, that input is to be derived with S always follows dollar, follow of S is dollar. And we have discussed if any production of the form A tends to alpha, A tends to, 1 minute, here we have a production like this, A tends to alpha, B, beta. Then what is follow of B? Follow of B, B is here, what B is following? Beta, means first of beta. If the beta contains epsilon, it means if the first of beta contains epsilon, if beta is becoming epsilon, what B can follow? Parent. Then follow of B, we can say it is follow of A, correct? Then follow of B is follow of A. These are the simple two rules for the follow set. And we have solved enough number of questions on first and follow, and exclusively on follow set questions are asked, or not on the first set so far, and two times question asked on follow set, exclusively follow set. Means you are given a grammar and asked to find which of the following is the follow set for that non-terminal. But so far question is not asked on first set, this is expected, means exclusively on the first set. It is not asked, it is expected. But first and follow is useful in all parsing techniques, that as you know it. But still a scope is there for asking 1 mark questions exclusively on the first set, and on follow set questions are already asked. Okay. Chalo, next one. It is MSQ and slightly different. Consider the following grammar, means slightly different way of asking the question. What is given? Some grammar given and asked set plus comma star will be in dash, plus comma star will be in dash. First of A is plus star epsilon. Okay, plus and star is there in the first of A is the answer. First of E, what is first of E? Is open parenthesis and first of A. What is first of A? Plus star and epsilon. When this is becoming epsilon, you are going to get first of E again. First of E again means again these same symbols are going to be repeated, but you do not get any epsilon. But what is asked? Plus comma star will be there. Okay, plus and star is there in the first of E also. Okay, this is also correct answer. Follow of E. Now what is follow of E? Where is E? Here. Follow of E is follow of E. So same symbols. Follow of E is follow of A. Okay. Follow of E is follow of A. Follow of E is follow of A means, and anyhow for E is a starting non-terminal dollar. Follow of E is follow of A. What A can follow? First of E. What is first of E? Open parenthesis plus and star. And what is fall of A? Fall of A is first of E. Fall of A is first of E. Here you look at fall of A is closing parenthesis, and fall of A is first of E. First of E, what is first of E? We have open parenthesis plus and star. That's it now. Fall of A is first of E and closing parenthesis. Now what is fall of E? Fall of A. So fall of E and fall of A both should be same. So that fall of E is first of E and close. No, okay. Because fall of A is first of E, I have written first of E no epsilon. Fall of A is first of E. So open parenthesis plus star. You don't get dollar in the fall of A. And fall of E is dollar and fall of A. Fall of E is dollar and fall of A. Dollar already written. What is fall of A? Closing parenthesis also there. You add closing parenthesis. And what is given? Plus comma star will be there in plus and star is there in the fall of E also. Plus and star is there in the fall of A also. Right? So what are the correct answers? All option A, B, C, D are the correct answers. This is also one of the question, and this kind of question asked. This kind of question asked on first and follow. Okay, so try to solve this question also. And first and follow is important in all the parsers, as I was keep on telling during my lectures also. Because the first and follow is the heart of the topic for the parsers. Because for all parsers, we'll be finding first and follow. Based on first and follow only, we'll be solving the parsers. If you do mistakes on first and follow, it means that the rest of the problem is wrong. Nothing to check. Rest of the problem is wrong directly, because the problem is based on first and follow. Suppose you haven't practiced much, at least now you practice it, so that you don't do any mistakes. What is given? Consider the grammar given below. S is okay. These are the production rules. Let C, D, E and dollar be indexed as. Okay, C is 1, D is 2, E is 3 and dollar is 4. Okay, these are the indexes given to C, D, E, dollar. Okay, indexed as. If P is the index values for the symbols in the follow set of the non-terminals S. Follow set for non-terminal S. Okay, it means you find follow of S. S is a starting non-terminal, follow of S is dollar. Okay, and where is S? Oh, nowhere. Follow of S is dollar, and dollar is indexed as 4. Okay, no more answers for this. And let this will be P, right? Okay, that will be P. Next is Q is the index values for the symbols in the follow set for the non-terminal A. So means it requires to find what is follow of A also. Follow of A. Where is A? Here, follow of A is C. Okay. And where is A? Here. It is first of B. What is first of B? E. Correct? E also there in the follow set. Follow of A is C and follow of A is first of B, E, and anywhere follow of A here also. Follow of A is follow of B. Follow of A is follow of B. Okay, I didn't calculate it follow of B. Okay, just I am writing here follow of B for later understanding. Okay, let R is the index values for the follow set for B. Okay, better we calculate follow set for B also, and after that I'll write the same follow of B here also. Now follow of B. look at fall of B here in this grammar, fall of B is first of A. What is first of A? First of A is first of A, repeatedly you can get the same symbols, D and epsilon. Okay, D I wrote, fall of B is first of A. I am just finding first of A. Please listen to me carefully. First of A, this is D possible, this is epsilon possible, it is first of A. Here this epsilon possible in the A, then C is also possible, right? Means what is fall of S, fall of B, first of A is D, C, epsilon. If because this is epsilon, fall of B is first of B also, correct? Fall of B is first of B also. What is first of B? E, wrote. Okay, I have considered only this B, okay. Look at only this B I have considered. First time when I look for fall of B, it is first of A is D, epsilon and first of A. This is epsilon, C. CD, epsilon possible. So, CD I have written, and because this is epsilon, fall of B is first of B is E, I have written it. And when you look for this, second time B, fall of B is fall of S, because after B we do not have any symbols, it is follow the parent, that is dollar. Fall of B is fall of S, dollar, already we have noted. And also you look at fall of B is fall of A, fall of B is fall of A, okay, just add it, fall of A, fall of B is fall of A, right? Okay, happy? Any more? Nothing. 3 possibilities are there, in all 3 possibilities have written. And when it looks to the fall of A, again you look at the fall of A. Fall of A, when you look for this A, fall of A is first of B, so I wrote E. And when you look for this, fall of A is C, C is also written. And here also there, fall of A is fall of B. 3 possibilities. And in the first possibilities, fall of A is B, that is E, fall of A is C, that is also written, and finally in the third possibility, fall of A is fall of B, and fall of B already have written it. Now what is the fall of B? D, C, E, dollar, C E already there, D and dollar I am writing, and here fall of A is C, E, D, dollar, already there. So means what is the final answer for this? C, D, E, dollar, and this is also C, D, E, dollar. Okay. So it is said P, Q, R. This is a P and this is a Q, this is R. But you observe it all in their ascending orders, all in their ascending orders. So keep in ascending order. Okay. Now P is dollar and only one, that is a 4. And what is fall of A, C, D, E, dollar? It is to be kept in ascending order. Now C is 1, D is 2, E is 3 and dollar is 4, this is Q. Q equals 1, 2, 3, 4 and R equal to 1, 2, 3, 4. These are the numbers, right? Now what is the question? Then the value of P plus Q plus R is. Now what is P? 4 plus Q 1, 2, 3, 4 plus R 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4. So how much it is? 2468, correct now? How much you are getting? Anything done? Okay, just let me check. Yeah. It is 1234, 1234. How much? 2468, correct now? 2468 plus 4. It is equals to 2468 72 is the answer for the question. Here I didn't do anything extra, same thing first and follow we have calculated, but the way of asking the question is different. So it is said arrange these follow symbols in the ascending order, and according to ascending order if you arrange it, you will get some indexes, you will get some number. That number is here P and here is Q, here is R, then what is the result of P plus Q plus R is a question. Now, what is the P plus Q plus R? 2472 is the answer. And there is a questions asked in the previous gate on predictive parsers, so far something around 6 to 7 questions are asked, and recently in 2024 also a question asked on predictive parser on parse table entries. Means what way you can expect a questions on predictive parser? You will be given a grammar and question is, if we construct a predictive parse table for the grammar, what is the entry in so and so row and so column? What is the entry? Dash. This is a one type of question. And the second type of question is, you are given a grammar and also will give a partially filled parse table. And the sum of the entries are numbered 1, 2, 3 and so on, and your question will be what is the entries in 1, 2, 3 and so on. Means they are giving a partially filled parse table and some of the entries are left as numbered cells and asked to know what is the entry in the numbered cells. So far they have asked questions on these two types, but what is expected? Apart from this, what is expected? The expected is could be a numerical question. The question is number of multiply defined entries. This kind of questions we have solved during the lectures. Multiply defined entries. How many entries are defined with multiple productions? And number of error entries. These are the possible type of numerical answer type questions. And question is also possible of type multiple selection questions. Suppose if it is given a table with a row and column, what entries are possible? That entries could be more than one entry because multiply defined entries are possible in the predictive parse table. If a multiply defined entry possible, it means that more than 2 productions appear in the same entry. So if more than 2 productions appear in the same entry, then option A some production 1, option B some production 2, C production 3, D production 4, maybe multiple productions may be possible. So if that is the case, it could be asked as MSQ. This is expected, means a numerical answer type questions are possible, expected, and MSQs are expected this time, because so far this kind of questions are already given. 6 to 7 questions are there in the previous year gate. And what is expected this way? So means don't expect 2025 paper as same like the previous papers. Expected slightly different. And don't expect easy also. Expect tougher paper only. So means you should be ready for the tough paper only. If you are ready for tough paper, those who prepare casually and those who didn't focus much on the concepts, they are going to be eliminated. You are going to be on top. That's why focus something different. And if multiply defined entries are possible in the predictive parser, means that grammar is not suitable for the predictive parser. If the grammar is not suitable for the predictive parser, then the question is which type of grammar is suitable for predictive parser. The grammar that is suitable for predictive parser is called LL-1 grammar. This is also expected. So far no question is given on LL-1 grammar. Exclusively on LL-1 grammar no question is given. When I can call a grammar is LL-1, it is not left recursive, it is not ambiguous, means if grammar is unambiguous, means if the grammar is ambiguous, it is not LL-1, grammar is left recursive, it is not LL-1, and any productions of the form A tends to alpha or beta, then the two conditions to be satisfied. What are the two conditions? That first of alpha intersection first of beta equal to pi, means there will be no common terminals in the first of alpha and first of beta. And what is the second rule? Suppose if the first of alpha containing epsilon, if the first of if first of alpha containing epsilon, then A tends to alpha you write in the fall of A, and A tends to beta you write in the first of beta. This should be pi. And same thing in the case of if beta containing epsilon. Suppose if beta is containing epsilon, then A tends to alpha you write in the first, and if beta is containing epsilon, that you can write in the fall of A. So means if one of the alternative containing epsilon, that alternative should write in the follow and other alternative write in the first. So these two intersection should be always pi. And this is a rule for LL-1 grammar. So far no question asked on LL-1. This time you can expect a question on LL-1. Okay, LL-1 grammar. Okay. Now we will see some of the questions so that we revise the topic, and also I will discuss some of the questions so that we can see expected type of questions. It is MCQ, multiple choice question, slightly different type of question. So means instead of giving the same question, same type of questions, I am giving some slightly different type of question. Have a look and try to answer. Look at size of the parsing table equal to number of cells in the parsing table. Okay, happy. Size of parsing table is number of cells in the parsing table. What is assertion given? Assertion given, a grammar has 5 non-terminals, means 5 rows you can expect. Grammar has 5 non-terminals and 3 terminals, means 3 columns, and the size of the LL-1 parsing table of the grammar is 15. Now tell me, is it correct? Is it correct? Okay, option. Majority people have selected option A. What is option A? Both A and R are true. But is it correct? It is false. This statement is false. Why? Because there are 3 terminals in the grammar. For every terminal we have 1 column. Along with that, we should have 1 column for dollar. So totally how many columns? 4 columns, means 5 rows, 4 columns. The size of the table should be 20, but it is mentioned 15. That is wrong. That is wrong. False statement. And what is reason? The size of LL-1 parsing table is the product of the number of non-terminals and number of terminals. Number of non-terminals and number of terminals. But number of non-terminals and number of terminals, okay, but plus 1 is required. Na? Number of terminals plus 1. What is that 1? 1 is called end marker dollar. That is why it is also false. So answer is both A and R are true, wrong. Both A and R are true, but R is not the correct explanation of A. But R is also not the correct explanation of A. R is, but it is mentioned both A and R are true, that is why wrong. If A is false, then R is also false. A is false means R is also false. Because what A is given? A is given 3 into 5, 15. What R is given? 3 into rows and number of terminals. That is also wrong. So that A is false, then R is also false. A is false, but R is true, wrong. R is also false. R is true if it is mentioned number of terminals plus 1, but plus 1 is not mentioned, so it is wrong. So answer is option C. Then, when it comes to the LL of 1 grammar, LL of 1, as I told you, what is when I can call a grammar is LL of 1? Now you look at in this question, we have multiply defined entries. If we have multiply defined entries, this grammar is not suitable for predictive parser. So that which grammars are suitable for predictive parsers? LL of 1 grammar is suitable. When I can call a grammar is LL of 1, if the productions of the form A tends to alpha or beta, it has to check the first of alpha intersection first of beta should be pi. Suppose if first of beta contains epsilon, if beta is containing epsilon, then alpha you write in the first of alpha and beta you write in the fall of A, and these two also should not be same to avoid the multiply defined entries. And we know that no ambiguous grammar is LL of 1. If the grammar is ambiguous, it is not LL of 1. No left recursive grammar is LL of 1. If the grammar is left recursive, then also it is not LL of 1. No ambiguous grammar is LL of 1. No left recursive grammar is LL of 1. And these rules to be satisfied. But exclusively on LL of 1, no question is given so far. But expected a question possible to come. How you can expect a question like this? So what is given? Which of the following is LL of 1 grammar? They have given multiple production rules like A, B, C, D are the different production rules, and which grammars are LL of 1? Check which grammars are LL of 1 and try to answer it. Is it MSQ? Look at the option D. Okay, whichever is easy, I will check it. It is both left recursive and right recursive. So we call the grammar is ambiguous. And ambiguous grammars are not LL of 1. That is very clear. Oof. But 2 students selected option D also. Okay. Next, look for option A. What is first of this first alternative? First of capital A, small b, because first of capital A is epsilon, then you are going to get symbol A. What is first of capital B, small a, capital B, small b? First of capital B, because first of capital B is epsilon A. So means both has the first terminal possible is A. It means on S row A column you write S tends to capital A, small b, and S tends to capital B, small a, capital B, small b. So means multiply defined entry is possible. So this is not LL of 1. So 2 options are eliminated. And look for option B. In option B, this is to be entered in small a, this is to be entered in small b column. So both the productions will go in different columns. Okay, happy. This will go into small b column, this will go into small a column, both will go into the different columns, no problem. Now when it comes to this will go into the A column because epsilon is there, this will go into the fall of B column. That will go into the fall of B column. If the fall of B also A, it means both will come in the same. If both will come in the same, it is not LL of 1. Okay. Now, we don't have any problem with the first 2 productions, but the last production you look at. What is the fall of B? Here you look. Fall of B is A. Just I am not doing it. Maybe other symbols are possible. It means B tends to AB, you write in the B row A column. B tends to epsilon, you write in the fall of B column. Fall of B is also A. In the column A, you write 2 productions. Because you write 2 productions in the column A, so B is also not LLF1, right? But almost 45% of the students have selected option B. Oh, so what is left is the answer. If you want, you can check. Where do you write this? S tends to capital A small a in first of capital A small a row. First of capital A is epsilon. So in the column A, we have to fill. S tends to capital B small b, where you have to fill S row first of capital B small b column. First of capital B is epsilon. So in the B column, we have to fill. This is to be filled in A column, this is to be filled in B column. Both will go in different columns. And anyhow, these are the single productions, we need not to check. The single productions means that only come. So there is no possibility of multiply defined productions. So answer for the question is option C. Next, we will go ahead with the bottom up parsers. In bottom up parsers, we have shift reduce parsers. We have shift reduce, and we have operator precedence parser, and we have LR of K parsers. Shift reduce, operator precedence, LR of K parsers. And questions was asked on shift reduce parser, on LR of K parsers. When it comes to operator precedence, so far only one question asked, that two, which of the following is operator grammar. Question is on operator grammar. What is operator grammar? Operator grammar has a property that no two non-terminals are adjacent and no epsilon in the right side of the production, means it is a null-free productions. It is a null-free grammar. Except that no more questions are asked on operator precedence, but on operator precedence parser have given some expected type of questions, like how to calculate precedence relations based on lead set, trail set, and finding the precedence relations. So these are the expected: finding lead set, trail set, and finding precedence relations between the pair of terminals, right? Lead set, trail set, and finding the precedence relations. That you have to check. Okay, lead set, trail set, and precedence relations on operator precedence parser. But only operator grammar questions were asked. This is asked, and these are all the expected time. And on shift reduce parser, I think only one question asked so far, but still there is a lot of scope is there for asking questions on shift reduce. And LR of K, enough number of questions are asked. Like it is asked about what type of grammar. The type of grammar means they have given some grammar and asked it that the grammar is LR of 0 or SLR of 1, LALR of 1 or LR of 1. So what type of grammar it is asked? That is a one type of question. And another type is they are giving some closure set. They are given some closure set and asked to find what is a go-to of that state I on some input. You will get some state, and that states will have some set of items. The question is how many items in the state. That is possible if you perform go to on that ith state on input, so that you will get jth state. On the jth state, how many items are there? This kind of questions. And also theory questions are asked. Theory questions asked on comparisons, like among all the LR parsers, LR of 1 is more powerful, and if a grammar is SLR of 1, it is also LALR of 1 and LR of 1, some kind of relationships between the LR family. That theory questions also asked. But multiple times, multiple questions asked on LR of K, on shift reduce one question, but more scope is there for asking some more questions on shift reduce. On operator precedence parser, so far question asked in grammar, but expected is on lead set, trail set, precedence relations. Questions are expected. Okay. So with respect to questions, we'll review the subject. Consider the following grammar, which of the following is true? It is on LR parsers. Check it, because we don't have X production, so you take it as small x. Okay. So I am changing this symbol X to small x, because if I am taking X as a capital X, then X production should be there, but X production is not there. So you can take it as a small x. Consider the following grammar: S tends to small x, or open L close, L tends to LAS. So here this S is capital, okay, sorry. Okay, LAS RS. Fine. Now question is, which of the following is true? Shift reduce conflict in LR of 0, SLR of 1, LALR of 1, none of the above. How do you find the items S dash tends to dot S? Because dot S productions we have tried, dot small x, and S tends to dot open parenthesis L closing parenthesis. And do we write L productions in the 0th state? We don't write. We should not write L productions in the 0th state. Why? Because we are not getting L productions with S. So it is a 0th state. So far we don't have any conflict. With S only one item possible, with X only one item possible. With open parenthesis we will get multiple items. If multiple items are there, means conflicts are possible. Open dot L close, dot L means L productions, L tends to dot LAS, and L tends to dot S. Because dot S is there, we write S productions again. S tends to dot X, S tends to dot X is one production, and another production is S tends to open L close, S tends to dot open L close. But do we have any conflicts in this? No. And with S only one item possible, with X only one item possible, right? With S you will get L tends to S dot, only one. With X, S tends to X dot, only one. With open parenthesis you are going to get the same thing, right? Because open dot L close, you are going to get the same thing. And with L you will get capital L, you will get one item, but later may be possible. Okay, I will write them. And with capital L, here these two possibilities, first and second, both are with dot followed by capital L. So what you are going to get? Open L dot close, right? Open L dot close, and S tends to L dot AS are possible. And any more items to be added, because after dot we have a closing parenthesis, that is a terminal. After dot we have a that is also terminal. No more productions are to be added. When it comes to the closing parenthesis, only one item possible. When it comes to the terminal A, what is possible? S tends to capital L small a dot capital S. Because dot capital S is there, capital S productions we have to add. Capital S productions are S tends to dot X is 1, and S tends to dot open L close is 1. Here also we do not get any conflict, and with respect to S only one item possible, X only one item. With open you will get this item again. But anywhere are you finding any conflicts? No. Because no conflicts, we can say the grammar is LR of 0. If it is LR of 0, definitely we can call it is SLR of 1, and also we can call LALR of 1, and also we can call LR of 1. When we can call grammar is LR of 0, if there is no conflicts, means neither shift reduce not reduce reduce. It means, do you have any conflicts in LR of 0? No. Because it is LR of 0 means it is also SLR of, means no conflicts in SLR of 1, no conflicts in LALR of 1, no conflicts in LR of 1. But what question is given? Shift reduce conflict in LR of 0, SLR of 1, LALR of 1. So answer for this question is none of the above, means there is no conflict in the grammar. So what is given in the question? Consider the parsing tables of SLR of 1 and LALR of 1. SLR of 1 and LALR of 1. Do you remember some point related to SLR of 1 and LALR of 1? Can anyone remember? What is the relation between SLR of 1 and LALR of 1? SLR of 1 and LALR of 1 both will have the same number of states. Do you remember? Okay, this point we have discussed. Consider the parsing tables of SLR of 1 and LALR of 1 for a context-free grammar. So, means both have same number of states. Number of states are same. Which of the following should be equal in both the tables? States anyhow equal, but what is given in option A, go to part? So, it is not asked about states, it is asked about go to part, reduce entries, error entries, shift entries. So, because both will have the same number of states, how do you find the states? States with respect to moving the dot with respect to terminal and non-terminal. Moving the dot with respect to terminal and non-terminal, you have to find the states. With respect to terminal, we can have a shift actions. With respect to non-terminals, we have to fill go to actions. Means go to part we have to fill. Because number of states are same, means moving dot one position to the right with respect to terminal, with respect to non-terminal, we are going to find the states. So, that number of shift and go to entries definitely be same. Go to part is same, shift entries are same. But reduces, is it same in both SLR of 1 and LALR of 1? In SLR of 1, reduces to be filled on the follow terminals. In LALR of 1, reduces to be filled in the look ahead terminals. And look aheads and follow is always same. Look aheads and follows are not always same. Because look aheads and follows are not always same, the reduce entries are not same. Reduce entries are not same. If reduce entries are not same, definitely error entries are not same. So, because it is to be filled in all follow terminals, it is to be filled only in the look ahead terminals. Whichever is unfilled entries are called error entries. Obviously, error entries are going to be more or less, like it is less in follow, so less in SLR of 1, more in LALR of 1. So, that error entries are also not same. What is same? Go to part and shift entries are same. That is, the answer is A and D. Okay, many students have given A and D also, fine, but some students have selected C also, but errors are different now. Let us say an example, A tends to A dot is there in some state, A tends to A dot is there in some state I. In the ith row in some column we have to fill reduces. Which columns we have to fill? Follow column, means only in the follow of A we have to fill. But when it comes to the LALR of 1, ith row is to be filled with look ahead symbols. Okay, ith row is to be filled with look ahead symbols. Suppose the state I has a item A tends to A dot is reduced, assuming look ahead is only A. But when it comes to the follow, this follow will have A and B. So, it means this A tends to A reduction you write in the A column and also you write in the B column in the case of SLR of 1. But in the case of LALR of 1, this is to be filled only in the look ahead column, right? A tends to A is to be filled in the look ahead column, means obviously B entry should be error entries. So, means here the B entry is not error in SLR of 1, here it is called error. So, obviously error entries are different, reduce entries are different. So, error and reduce entries are different, but go to and shift entries are same. That is the meaning of the question. I think it is clear, correct? Next, that's about parsing, and those are the kind of questions possible, right? Those are the questions possible. And next, we'll go ahead with the syntax directed translation. There is a next chapter. In syntax directed translation, this is a small topic, and frequently questions are coming. What is syntax directed translation? Syntax directed translation is for defining semantic actions with the grammar productions. For defining semantic actions with the grammar productions, we have two notations. One is syntax directed definition, and second one is a translation scheme. There are two notations. From each of the notation, questions were asked previously, and still there is a lot of scope to ask questions on this. In syntax directed definition, the attributes are attached to the grammar productions. What are the attributes that are attached to the grammar productions? Synthesized attributes, and second type is inherited attributes. There are two types of attributes that can be attached to the grammar productions: synthesized attributes and inherited attributes. There are two types of attributes attached, and synthesized attributes are evaluated during bottom up traversal of the parse tree, and inherited attributes can be evaluated from how it can be evaluated, because inherited attributes are evaluated, are defined with respect to parent and siblings. Parent and or siblings. Based on the dependencies, that is going to be evaluated. And there are two types of syntax directed definition: S attributed and L attributed. When we can call SDD is S attributed. We can call it is S attributed if only synthesized attributes are there in the grammar. If there are only synthesized attributes, we call it is S attributed grammar. What is L attributed syntax directed definition? The question was asked on S attributed and L attributed. If it has synthesized and are inherited attributes, then it is called L attributed grammar. But we have a condition for L attributed, that is, an attribute is defined in terms of parent and in terms of left sibling, but not from right sibling. Right sibling should not be allowed. If it is inherited attribute, there is a condition that it should be evaluated from parent and or left sibling, but not from the right sibling. So that every S attributed grammar is also called L attributed, but every L attributed grammar need not be S attributed. There is a relation between S and L. Enough number of questions we have solved in the classroom and during live classes about syntax directed definition. In the translation scheme, semantic rule is within the grammar production. Semantic rule is within the grammar production. And how these semantics are to be evaluated? Using depth first traversal of a parse tree. Perform depth first traversal of a parse tree and find the output for the input sentence. That's it about syntax directed translation. So only two topics. Among the two topics, 99% you can expect a question from one of the topic. When it comes to SDD, we have synthesized attribute, inherited attributes, again S attributed grammar, L attributed grammar relationship. When in the case of translation scheme, you have semantic rules within the grammar productions, perform a depth first traversal to find output for the input sentence. That's it. Enough questions we have solved during the live classes and during the physical classes. And here are few questions to revise the topic. Just check one of the simple question here I am asking. How you have to find what type of SDD? Okay. A tends to B, C, D is a grammar protection and it is a partial for this. When you look for the dependencies, C dot P, P is an attribute which is defined with respect to parent A dot P and the left sibling B dot P and also from the right sibling D dot P. Because it is defined in terms of parent and sibling, we can call P is inherited attribute. If it is inherited attribute, it is not S attributed grammar. First thing, because inherited attribute, it is not S attributed. And it may be L attributed. If it is to be L attributed, there is a condition on inherited attribute, that is, it should be evaluated from parent, left sibling, but not from right sibling. But evaluating from right sibling, so we can call it is not L attributed. So it is not S, not L. So answer for this question is option D. Is it clear? Done. But some people have given A, B, C also. But check it out what mistake you have done. Hope you have understood this concept at least now. And this is a question on SDD. We have solved enough problems during the live classes and offline classes, but still solve at least one question for the review. Okay. This is SDD given, and here is the input string. Then the value of the starting symbol S is for the parse string. Now, what is the output for the input sentence? Solve it. Okay, this is a subscripted number. S tends to L, L tends to L1B. L1B means L1 is a subscript. L1 is an instance of L. L1 means L only. Just to understand the semantic rule, it is given a subscripted number. I think we have solved this kind of questions. L1 is not a separate non-terminal. L1 is same as L. Consider the syntax directed translation scheme given below. Now, what is the output for this input sentence? S tends to L, L tends to LB, L tends to LB because 4 bits are there. L tends to LB and L tends to B. 4 B's are there. And this B tends to 0, this B tends to 0, this B is 1, this B is 0. Okay. Now, parse tree is constructed. Now, evaluate the tree according to the semantic rules. Now, what is the semantic rule for B tends to 0, value equal to 1? Wherever 0 is there, that value is going to become 1. B tends to 1 means wherever 1 is there, that value is become 0. Now, L tends to B had a semantic rule, L value equal to B value, that is 1. And L tends to LB had a semantic rule, L value equal to L value into 2 plus B value, means 1 into 2 plus 1, that is 3. Again, L tends to LB has a semantic rule, L value into 2 plus B value, 3 into 2, 6 plus 0, 6. This is 2 into 6, 12 plus 1, 13. S tends to L had a semantic rule, S value equal to L value, 13. So, means what is the answer for the question? 13. What happened here? Simply the input is 0, 0, 1, 0. It is complementing 1, 1, 0, 1 and finding its decimal value, that is 13. That you can understand from the example and translation. Shubha, 2, wrong answer. So, it is 13, 13 is the right answer. Okay. So, what is happening? 0 changes to 1, 1 changes to 0, then it is evaluating a binary to decimal conversion. That is it. That is the semantic actions. And there is a question on translation scheme. On this also we have discussed multiple questions. Just find the answer for this question. Very simple. Derive the input. How to derive the input? Start with this S. We have to get A, so that S tends to small a capital A, and we have a print 3, A derived. Now we have to elaborate capital A. Now get B. We should not use the second production, we should use the first production, because if you use the second production, that is the end of the input. So we go with the first production, B, what is the semantic? Print 6. B derived. Next A I wanted using B. I cannot use the second production because it is ending the input, but some more input is there. So we go with SC and print 9, and so last part is derived. Now still we have to get A with S. So first production we have to use A print 3, so A derived. Finally we have to get B from A. To get only B from A, you have to use the second alternative. So it is to derive 6. Now look at when you perform a depth first traversal, what output you are getting? The output you are getting is 63963 is the answer for the question. So what is the scope? I have explained. The scope is what type of SDD, questions on SDD and questions on translation scheme. That's it. So you can expect minimum one question from this chapter, compulsory, because when you look for past 10 years of papers, every year, past 10 years I am talking, not just 1-2 years, past 10 years, every year one question is there from the chapter. Small chapter, less number of topics, easy questions. Next, we go ahead, the next chapter called intermediate code generation. Intermediate code generation. Intermediate code generation. In intermediate code, what are the topics are there? The intermediate code forms. Those are called, what are the intermediate code forms? Linear intermediate representation, structural intermediate representation, and hybrid intermediate representation. In linear intermediate representation, we have a postfix form, 3 address code, static single assignment form, and postfix is outdated. And when it comes to the structural intermediate representation, syntax tree and directed acyclic graph. And the hybrid intermediate representation, control flow graph. So except postfix and syntax tree, in the remaining 4 types, questions are possible to be asked. Questions were asked on SSA, DAG and control flow graph, but no question is asked so far on TAC, the number of variables. So it is expected. So what kind of questions are possible to be asked? In TAC, there are 3 implementations. What are the 3 implementations of TAC? Quadruples, triples, indirect triples. In 2024, a question asked on triples, and the remaining 2 are expected topics. A question may be possible to be asked on quadruples and indirect triples. And also expected question on the minimum number of variables. You are given an expression and asked to find how many variables are needed to get a minimum TS. and question is asked on SSA on minimum number of variables, and 2 times it is asked on SSA. DAG, you will be getting a question on number of nodes and edges. And control flow graph also, we have a question on number of nodes and edges. Even in 2024, one question asked on control flow graph. But overall, if you see, the total number of questions in the previous gate are less, because number of questions are less, more scope is there for asking questions. More questions are possible to be asked from this topic, because so far less number of questions only asked, but still they can find more ways to ask the questions on the topic. But do remember one thing, concept never going to be changed, but what is going to be changed, the way they are going to ask the questions are going to be changed. So how they are going to ask the questions, you should be ready in whatever the way they ask you. When you are able to answer the question, if you are confident with the concept, then you can able to answer the questions. So be confident on the topics, because I have explained expected type of questions also in the physical class and live classes. So you can expect a question on these topics. These are the expected, and those are the questions that were asked. Now this is a question on minimum variables required for the following TSC code. How many minimum variables are required for the following TSC code? Check this. Find how to solve this. A minus B, it is to be evaluated, and it is stored into different variables, because when I am talking about minimum variables, storing into a different variable is not required. I can store into A, same variable. This P is used here, here I can say A. Now A star C, that is stored into Q, because that is stored into Q, I can store into A. So this Q I am changing to A, and this Q is used here, so here also we can use A. And next U star V, it is stored into P, so no need of different variable, I can use U only. So this is U, and this P is used here, this is U. So means finally U plus A equal to Q. Q is not required, you can use U or A, sufficient. Now this is a TSC with minimum variables. What are the variables used? A, B, C, U and V. That's it now. A, B, C, U and V. How many variables are needed? Totally 5 variables. Okay. Chalo, next. The minimum number of total variables required to convert the code into static single assignment form. Okay. This one you try. Okay. Make it simple. How do you do this? U plus T assigned to X. Okay. It is assigned to different variable. U star V assigned to Y. This is also assigned to different variable. Y plus W assigned to X. X already there. So you make it X1. This is X1 means here also X1. X1 division Z, that is assigned to Y. Y already there. You can make it to Y1. That's it. Over. What are the variables? X, Y, Z, U, V, T. Correct? W. W, X, Y, Z, U, V, T already there. Along with what we have added? X1, Y1 newly. Okay, just I am checking again with the code. X, U, T, first statement. Okay, X, U, T. Second statement U, V, Y. Third statement Y, W, X1. And fourth statement X1, Z, okay, X1, Z, Y1. Perfect, na? So how many variables? 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 variables are sufficient. That's it. The next we'll go ahead with the directed acyclic graph, DAG. directed acyclic graph. In short, we call DAG. What is for DAG? DAG is used to eliminate, used for the elimination of common sub expressions, means it is to identify common sub expressions, dead code eliminations, and it will be used for optimal register allocation required in the target code to be generated and all. Suppose we have A star B plus A star B. In the case of syntax tree, what we have to do, we have to create a node for A, B and star for the first one, A, B star for the second one, and create a node for plus and assign to this. This is we call syntax tree. In syntax tree, each node can be defined for multiple times. But when in the case of DAG, each node is defined only for one time. Node for A, B, and next time node for A, B star already there, we have to use it. We should not recreate it. Now node for plus, whose adjacent nodes are these two. So we can call A star B is T1. So T1 is already defined. Next time A star B is T2. So again we can say it is T2. And next is T1 plus T2. Okay, done, over. Now this is a DAG. In DAG, each node is defined only for one time. There is a difference between DAG and syntax tree. So far questions are asked, how many nodes and edges in the DAG? Here how many nodes? 1, 2, 3, 4 nodes. How many edges? 4 edges. The number of nodes and edges is the question asked on DAG, right? Just a slightly different question. Okay, look at insider. The node whose degree is strictly greater than 1. The node whose degree is strictly greater than 1. That is defined as insider. Okay, this is a different way of asking question. The number of insiders in the DAG of the expression. Have you understood the question? So it is defined what is insider and asked to find the number of insiders. Node for A, node for B, node for plus, adjacent nodes are A and B, you call it as T1. Okay, it is T1. And node for A already there, node for D, okay, and between them we have a minus A and D. A minus D, okay. Don't worry about left or right. This is a graph. You can have left or right, no issue. This one you can call T2. Now between T1 and T2 we have a multiplication. That's it. That is the final result I can call T3. Now what is the meaning of insider? Insider means the node whose degree is strictly greater than 3. Degree is nothing but number of edges. Strictly greater than 1. Greater than 1 means it will be minimum 2, 3, 4, anything, but not be 1. Greater than 1. Any value greater than 1 is insider. Now what is the degree for this 2? Here 2, here 2, this is also 2. And these degrees are 1, only 1 edges are there. So how many insiders are there? Now 4. Answer is 4. We will move to the optimization. On optimization, very little number of questions are asked, but definitely I feel those questions are good questions. Those questions are good questions. On optimization, we have discussed about basic block. What is a basic block? Basic block is a sequence of consecutive statements in which control enters at the beginning and leaves at the end, and there is no halting, no branching. Is a basic block, right? How basic blocks are to be identified? By identifying the leader statement. What is a leader statement? First statement of a program is a leader. Target of a go to statement is a leader. the immediate next statement after go to is also a leader. So, we have seen that rules, so that we can divide the program into basic blocks. And each basic block you assume it as one node, and transfer of a control from one block to another block is represented as edge, and that representation is called control flow graph. Questions were asked on basic blocks and control flow graphs. Questions were asked, something around 3 questions are asked so far, and recently in 2024 paper also one question asked on control flow graph, right? And optimization is going to be performed on a basic block. By considering only the statements of basic blocks, we call local optimization, or by considering the statements of other blocks, we call it as a global optimization. We have local scope and global scope. We have 2 scopes for optimization, local and global optimization. Local optimization followed by global optimization, right? Local and global optimization. In local optimization, we have discussed the techniques: common sub-expression elimination, dead code elimination, and copy propagation, constant propagation, constant folding, strength reduction. These are the techniques we have discussed. On these techniques, you can expect some theoretical questions, some theory questions you can expect. And in 2021, one question asked on common sub-expression elimination. That 2 marks question, one program snippet is given and asked to perform common sub-expression elimination optimization, and asked about number of additions and multiplication operations in the resultant code. In a global optimization can be performed by using the control flow analysis and data flow analysis. For control flow analysis, we use control flow graph. For data flow analysis, we use data flow properties. What are the data flow properties? We have discussed available expressions, busy expressions, available expressions, busy expressions, reaching definitions, and live variables. And undoubtedly live variables are important, because in 2021 asked, again a question asked in 2023, 2 times asked. In 2021 it is a 1 mark question, theoretical question on data flow equations. In 2023 one good question asked on live variables. Okay, so these are the possibilities, but less number of questions, but good questions are asked. So give more importance on optimization. Oh, is it MSQ? Oh, it is MSQ. Fine. Sorry, it is MSQ. So input lines for code optimization given, output of code optimization is given. These are the inputs, these are the outputs. Now question is, what techniques are applied by code optimizer? First, common sub-expressions. There are no common sub-expression. By looking we can understand. Dead code elimination, copy propagation, jamming. Loop jamming is in loops, no common sub-expression. Is copy propagation done? It is a copy statement, and C here, if that is replaced with B, it is called copy propagation. Yes, that is replaced with B. Copy propagation is applied. Once copy propagation is applied, there is no use of C equal to B, then it is called dead. That is removed, so not there in the final code. Then I can call it is dead code. So it is both B and C. Okay, it is both B and C. Done. And question is asked on this number of leader statements, basic blocks and all. Okay, it is one question, and that is MSQ. Okay. Statement 3 is a leader. Number of leaders of given code is 3. Number of basic blocks is 2. Statement 5 is not a leader. Okay. First statement of a program is leader and target of go to is a leader. So, how many leaders? 2 leaders. 2 leaders means 2 basic blocks. Simple. Statement 3 is a leader, true statement. Number of leaders of given code is 3. Do you have a third leader? No. First statement is a leader, target is a leader, next statement after target is a leader, but 13th statement is not given. If 13th statement could have been given, then 3 leaders are correct. And number of basic blocks is 2, perfect, 2 basic blocks. That is 1 and 2, 1 basic block, and 3 to end is 1 basic block. And statement 5 is not a leader, that is also correct. 5 is not a basic, now 5 is not a leader. So, answer is A, C, D. Okay. The 44th question. Consider the following basic blocks. What are the variables that will be live at the beginning of the basic block? At the beginning of the basic block means, suppose assuming this is a basic block B, it is asking in value of B. What is the in value of B? The set of variables live incoming into the block B. So, means at the entry point of block B, which variables are live is a question. So, it is MSQ. When I can call a variable is live? A variable is live at some point P in the program. If from that point to the exit, there should be some path. In that path, the variable is going to be used before it is redefined. If it is used before it is redefined, we can call the variable is live at that point P in the program, otherwise the variable is dead or killed. So, means at point before the block B, you can check. So, on entry point of the block B, you can check which variables are live. So, B is used before it is redefined. The 2 is a constant, that is not a variable. And after B used, it is redefined, okay, no issue. And A is used, but when it is using, after it is redefining. It means at the entry point of block B, A is not live, because A is going to be redefined. After this point, A is going to be redefined. And D is used before use, there are no redefinition. And what about C? C is also used, but after used the value of C, then it is evaluated and result is given to C. So, means it is redefined after use, not before use. Okay, C is also there. A used, but after definition. C here used after redefinition, means here this point is not useful. But I have to talk about E. E, there is a use, but before that any redefinitions? No. So, means which variables are live incoming into the block B? B, C, D, E, all variables. B, C, D. But E is not given. Option A is given A, but A is not live at the entry point, because at this point to exit, there should be a use, but use should be before redefinition. Here there is a use, but use is after redefinition. That is why A is not live. So, option A is wrong. Answer is option B, C, D. And hope you have enjoyed this session. And just I am going to end up the session with some motivational quotation. In life, winning and losing will both happen. what is never acceptable is quitting. Already you have come to the end, hardly 10 more days for your GATE exam. Don't worry about whether you are going to win the race or lose the race, means whether you are going to get a good rank or not getting a good rank. So, but definitely you are going to win means someone going to lose, definitely, right? You are going to win means suppose you are going to get some good rank, one rank, then someone should get some other rank, okay? So, don't worry about winning and lose, but give your best and you never accept quitting. So, ऐसा मत सोचिए मुझसे नहीं हो पा रहे चलो मैं छोड़ दूंगा. ये बात मैंने बहुत सारे स्टूडेंट से देखा. छोड़ने का बात ही मत करो. और 10 दिन है. Still 10 more days are left. So you can give your best in these 10 days. Maybe you are getting something around 20 marks. In these 10 days, you can take this one to 30, 40, 50 marks also, if your strategy is good. So never accept that you are going to quit the race. So go ahead and don't think about winning and losing and give your best. Never accept quitting. And this one with this I can end up this session, and I'm going to end up the session by saying you thank you for your patience for attending this session, and always yours Ramesh Masuna Sir. Thank you. Bye-bye.